So, good morning, all of you. So, we are in the third day of our GAN course uh, on microfabrication technique and device integration principles, processes, and application. So, this is tutorial number 3. So, I'll be talking about application of operation research in manufacturing industries. So, my outline will be first we'll know what do you mean by operations, then what is research, then combining both of them, what is operations research, then what for it is required for manufacturing industry. Okay, then after that we'll be going for different types of industries. Okay, how we can classify industries, then specifically what manufacturing industry says, then we'll be dealing in different types of manufacturing industries or production processes, production plants. Then we'll be discussing different types of plants. Then on what field we can apply operation research in manufacturing industry and what is the benefit out of it. Then also I'll be citing about a special concept, that is theory of constraints, which is nowadays it is applied to all the organizations, manufacturing organizations specifically. Then we'll go for a case study. We'll go for modeling one operation process, manufacturing operation process, then formulate a problem. We'll discuss about a case study. Now, to start with, operation research. Operations, it is basically, it's a scientific study of different operations for making better decisions. So, our aim is to get a better decision. You can say operation, it is both a combination of both arts and science, and arts is required where you apply your mental IQ, and science, different scientific principles, if we apply in operations, then it becomes a science. Then what we generally do here, we formulate the problems that is being faced in industry, then we find a solution for that, then there may be many solutions or many alternate solutions may be available. So out of that we take a decision. Then research means it is mostly the observations and testings characterized by scientific methods. And what can be the research? It based on different situations that arises in industry, okay, or different top tasks that is faced by industry. Then you will formulate the problem statement you are to define, then you are to model it, then you are to validate it, because before directly applying it in the soft floor, so first you will take everything and go for modeling, analysis, simulation, analysis, whatever in computer. So after modeling, you will then validate it by experimenting. Then you will find the solution. So combining these two operations research, we can say it's a quantitative approach to decision making based on scientific methods of problem solving. Now, we can say operation research applies analytical method to decision makings. It helps in optimizing manufacturing processes, thereby reducing costs and thereby improving the efficiency of the plant. It is widely used for production planning, production scheduling, and mostly supply chain management. Then, what is this? As I already explained, so you are to optimize the decisions. It's a mathematical discipline focused on optimizing complex decision making processes. Then you have to go for modeling and algorithm by utilizing modeling, simulation, and advanced algorithm to identify the best or near best solution to intricate problems. Now, optimization is such an area that you cannot go for always the best. There may be near to best solution also. Okay, and maybe we may try by some other method, or somebody else may try to improvise this. So we cannot say this is the best method always. Okay, like in your +2 career, you might have solved that maximization, minimization by gradient method or derivative method. So there you get a pinpoint optimization, optimum value. But always it doesn't happen in industry, because the problem formulation and all the functions you cannot get the derivative and equate it to zero, then find a critical point or critical solution. So always you can't do that. Okay, there are implicit functions also where it is difficult. So we go for some iterative methods also. So either you may find the best or nearby solution to integrate the problem. Then industry vitality. Now look, this operation research first during World War II for moving their military logistics, because World War II, in the whole world, the war was going on here, and in a more sophisticated manner. What happened? Those for transporting military logistics in a time bound manner and moving also military personnel. So first this operation research is being applied. Now this is more applied to manufacturing industries mostly, and also to service industry you may apply it. Like you might have heard of transport traveling salesman problem. Traveling salesman problem means those who are in marketing personnel. Suppose you can say medical representative. Suppose in a particular district or particular or 2 to 3 districts a particular person is handling, and he needs to go to different doctors, and for a monthly planner, by which way or who are the doctors, in what way, what fashion he can travel to them, so that he can optimize, I mean, in less time and covering less distance, he can touch upon all the doctors or maximum doctors. So it's a very difficult task if the number of doctors, their locations, and you have got limited time. So for all these planner, traveling salesman problem is very popular. Again, though it's not a manufacturing industry, it's a servicing industry. So there also you can apply this operation research, and then most widely applied in manufacturing industry. Now, basically, industry, there are two types of industry. One is service industry, other is manufacturing industry. Let us say engineering institutions, universities. Can you consider them as university industry? Yes or no? No. Huh? No. Oh yes, yes. Okay. Look, even our institute, it's a it's an industry. Though it is not manufacturing anything, you can say it's set of service industries. Industry means basically you have got some input, you will be getting some output, and in between some processing occurs. Okay, so we get mostly input as 10+2 students, and we do some processing, and the final product becomes graduate engineers, or we take graduate engineers as input, then some processing is done here, so finally they got a PG, they become a PG student. Okay, so where input having some processes into it, get some output, these are called industry. Now if you produce raw material, some raw materials are required, and you use these 5 M's. What are these M's? Man, machine, material, money, and method. So you incorporate all these into raw materials, then you will get the final finished product. Then only it will be manufacturing industry. Service industries, mostly your best example is your health industry. So a person who is ill, he comes as an input. Then you always, this is not employed there. Some processing is done, then he becomes well and he goes back. So mostly health, education, insurance, these are all, they come to banking, they come under service industry. Okay, And you will find in government sector, most corruptions are in the service industries. And mostly these are no profit, no loss industry. Okay. Forget about banking. In education industry, we do not make any profit. For health industry, hospitals and all, government hospitals, but we do not earn any money out of it. Okay. So anyway, but we'll be mostly focusing on manufacturing industry. Okay. Now, then what are the techniques? Look, it's a very vast topic. Operation research, you will, those, those who are graduates or postgraduates out, sorry, postgraduates or PhD out here, they might have covered that transportation assignment problem in operation research is there in there. But BTech, they will be following this in their maybe final year or pre-final year. So it's very difficult to cover up the whole thing in 2 hours. I'll just be touching upon just to know where it can be applied. Now, the most favored one is your linear programming. Okay, linear programming means for optimizing anything, you require an objective function. What you need to optimize? Optimize means either you want to maximize or you want to minimize. That is your objective function. Then, if there is no constraint, like you are optimizing some function in a +2, so the method you are doing, so there no constraint was there. But if I add some constraints, suppose say my objective function is a function of time, say, but I have got a limit of time. The time cannot be less than say 30 units. That means I am putting one equality constraint, or it's a multivariable problem, say both time and volume. Then I may say, okay, time will be in between this minimum value lower bound to upper bound. So we'll call them as bounding constant. Or I can say, okay, I may have some relation, say 2 times time plus 3 times volume, whatever, the empirical value should be 50 or something. So then it becomes equality constant. So if I put some restriction, then it becomes constraint optimization. Okay. So mostly linear programming means where all objective functions and the constraint equations all are linear. Linear means highest power is 1. The maximum degree is 1. Then we call it as linear programming. Or you can say LPP, linear programming problem. So mostly in industries, this has got wide application. I will be telling how it is applied. Then if any one of these equations, either constant equation or objective function, becomes non-linear, we call it NLP, non-linear programming. Anyway, next is queuing theory. It manages the waiting lines and production flow, because always all organizations, they want to utilize their resources to the fullest. Maybe it is human resource, maybe it is their machines, maybe it is their personnel, or maybe their space. So everything they want to utilize to the optimum level. So there should not be any waiting line. So how to utilize them? Yeah, queuing theory tells the best about this. Then simulation, modeling real world manufacturing system. Then inventory model. I'll be coming to this while I'll be discussing different types of things. Then inventory also, it becomes an important thing. Inventory, look, it may be a biggest headache for any manufacturing organization. Mostly in American technology, American concept, there are two concepts, American concept and Japanese concept in this inventory. Okay. Now, in American concept, we keep inventory in stock. Okay. Depending on our requirement. Why do we keep? Because if suddenly some unwanted demand comes, then how to meet that demand? Okay. So to meet that, so that we cannot lose our name in the market. So for that, we'll keep inventory in stock. Okay. But in Japanese concept, what happens? They do not believe in keeping inventory at stock. Because if you keep inventory in stock, there will be a inventory carrying cost. You require a space, you require a warehouse or go down or some space to keep the inventory. Again, depending on the type of inventory, whether it has, what is the lifespan of that inventory. Suppose say rice, I cannot purchase rice for 6 months and keep. Then there will be insects inside it. Okay. Similarly, I cannot, similar sort of thing which are perishable things or which may damage. So, so that you need to, yeah. And inventory keeping techniques also you have to follow, because it requires proper lighting. Maybe for some inventory, air circulation, some inventory, it needs to be, the place needs to be rotated, changed. So it becomes a bigger headache. Now, and also you require to keep watch and ward. So for inventory carrying cost, it involves money. But in Japanese concept, what they believe, they have got some faithful vendors associated with them. Okay. So whenever, at what point, what and which point of time you require any inventory, they will just make yourself available at that point. That is known as JIT, just in time concept. Okay. There is another Japanese concept, that is Kanban. Kanban means it's a card which gives for an order or demand. Okay, you supply this material to us. So the card moves from vendors to vendor or stores to store. Yeah, then you get the material. Anyway, so for different inventory modeling, control raw materials and finished good levels. Similarly, you cannot produce things and keep it stacking, because you can make money only when you will sell your product. Okay, then only you will earn money. So it's not that you will produce and keep it in your godown. The networking model, so it optimizes logistics and distribution also. This is again, you think of Amazon, Flipkart, whatever online mode is there. So I ordered something. If it is not available in my nearby Guwahati, it comes from Kolkata. If it is not available in Kolkata, it comes from Karnataka, or it may come from Haryana. So whatever stores, so the so it's logistic management. Again, they take the help of this OR. Okay, OR maybe some programming, the algorithm, some algorithm they have to write, they have to run the program, so it works automatically. Now, in production planning and scheduling, it helps in allocating resource effectively, develop schedules to minimize idle time, ensures timely delivery of products, then it balances machine workload and labor availability. Then in inventory management, as I already told you, OR models determine optimal stock level, because you cannot keep more stock, also you cannot keep less stock. Suppose less stock, where it happens, suppose in every month end I used to buy rice through online mode. But okay, and I know that generally it takes 2 days or 3 days. If just before 3 days before the month end, if I order, suppose some untoward incident happened, maybe some storm or the road is blocked, it's jammed, it may take 7 days. So in that case, for rest 4 days, you will be having no rice. That means for optimal stock level, you have to maintain. Okay, to meet some untoward situation. Then reduce holding and shortage cost. Again, if you have shortage also, it will lead to some cost and losses. And if you are holding it for a longer time, again it is associated with a cost. So depending all this, the economic order quantity model, EOQs, are decided. Economic order quantity means there is certain quantity, it has got a mathematical formulation you will be knowing. So you will decide at a time how much quantity you should order, so that you will be at no profit, no loss situation. You will be not at loss. Then just-in-time system supported by OR tools. Again, in the just-in-time Japanese concept and American concept, what is the difference? In Japanese concept, just-in-time concept means I am the manufacturer. Say he is one of my faithful vendor, he is another vendor. So I deal with only these 2 to 3 vendors. Okay, so they will think for me, I'll also think for them. They will think for me means They know what are my limitations, what are my requirement here. So in time or on timely delivery, they will provide to me. Okay. And at the same time also, I should be very regular in paying back the money, their money. Okay. So maybe they charge some little more extra cost than usual, but due to our faithfulness, so working is easy. But in inventory stock, what generally you do? You go for quotations, tenders, then whoever quotes the lowest price, that you buy. So every time you need to spend some money for ordering, that is known as ordering cost. Okay. So maybe this time he got the lowest price, I'll buy from him. Next time he got the lowest price, I'll buy from him. Okay. So Japanese concept is a family concept, but in American concept, it is hiring and firing concept. If I require, I'll hire. If I don't require, I'll fire. Okay. Now, again, quality control and reliability also. Now, today to sustain in market, so this is the first criteria you have to meet, quality. In earlier days, what we used to do, first we go for producing the product. At the end, if we see, okay, this is not up to the mark, we used to reject the whole thing. But the concept has changed. To minimize the scrap, to minimize the loss, at each point of time, during the production, before production, after production, at each interval, we go for quality and inspection at each point of time, so that the scraps or number of rejects are minimum, they're reduced. Okay. So to check quality and reliability. So statistical quality control, SQC techniques, reliability engineering for machines, then preventive maintenance planning, then it enhances product quality and customer satisfaction. Then supply chain and logistic optimization, operation research methods optimize transportation routes, minimize supply chain cost, improve distribution efficiency, then demand forecasting and resource allocation. Again, forecasting is also necessary, because unless until you have a vision, your prediction is correct, so you cannot go for manufacturing. So you take, maybe you will be taking prehistoric data, all past data. So from that you will go for forecasting the things, and accordingly you will manufacture. And after forecast means it occurs beforehand. Suppose I have forecasted 500 unit, so 500 unit I produce, but the sale is, the demand for that period is say 480. That means 20 will be remaining. Maybe next time, or it may be 520, 20 may be extra. So I'll calculate the forecasting error, then analyze and rectify my forecasting method. Case studies in automotive industry, optimized assembly line scheduling. Assembly line balancing is also important. In electronics, improved demand forecasting. All fast moving consumer goods. Fast moving consumer goods, your soap, oil, then any food item you can say, which are fast moving. I mean, on day to day basis, you do not require it occasionally. On day to day basis, it is required. So reduced inventory cost with OR models. Then in aerospace, simulation for reliability and maintenance. Now look, operation, due to operation research also, the you might have checked one flight trader. Flight trader, you can see the position of the flight at a particular point of time in any region in the world. Okay, you see how dense it is. I mean, how this is managed, at what height an aeroplane should fly, at what altitude, at what speed, and at what position. So this is a very difficult modeling. So by operation research also, their movement is possible, or the ticket booking. Again, they apply operation research for that, because for their operational procedure, say Kolkata to Silchar flight is coming. So for one operation minimum, how much they want. So initially what they do, the number of seats with higher prices, they block it. And they see what is the demand, what is the heat per day or for a particular period, per hour. Okay. And depending on that, the price fluctuates. So after all these are over, then they see what is the demand again. If demand is more, again the flight, the cost will be more. If it is less, then they gradually reduce it. Okay. And at the last moment, you can see the flight ticket becomes less. Okay. So now, these are the different types of manufacturing systems: continuous manufacturing, batch manufacturing, job shop manufacturing, discrete manufacturing, repetitive manufacturing, three-dimensional printing, custom manufacturing, flexible manufacturing, process manufacturing, intermittent manufacturing system, mass customization, lean manufacturing, make to assemble, make to order, and mass production. So you can categorize them to all these types. Now, just to highlight, now look how they are classified. So this is a graph between production volume. Okay, that means quantity, and this is variety, means type. Okay, understood? Or this is otherwise known as PQ curve. P means product, I mean number of products. What are the varieties? And this is volume, quantity, Q, volume. Look, continuous production, mass production, batch production, job shop production. Job shop production means it is versatile in nature. Okay, suppose I have one lathe machine. Okay, that means I can do variety of work. What is variety of work? If somebody comes, okay, I want this bore, dia should be increased. Okay, I'll do. I want this diameter should be chopped up, reduced. I can do that. Or this threading is done. I can do that. So you can get variety of design, variety of products. That is job shop or say carpenter shop. If I want this teapot, okay, I'll give the design, he can produce. If I want this sofa set, if I want this bench, if I want this chair, if I want this table, so you give him the design, he will give. So that is job shop production means variety is more, but quantity is less. Okay. But for mass production, you have variety is less, quantity is more. So how to decide? So for low variety or low type and quantity is more, you go for continuous production. The next, mass production. Then go for batches, batch production. In each batch, you go for one quantity. Okay. Then job shop production where more variety is there, but quantity is less. Now, continuous manufacturing, that is your mass manufacturing. Anyway, for mass manufacturing, there is no storehouse or raw material needed. Continuously it comes and things are produced and it goes out immediately. Okay. Like you can say, okay, the tea garden. Suppose in our tea garden, I mean the same day the tea has to be manufactured. Suppose every day in the season, every day they are plucking the tea leaves and the factory runs. Immediately the tea is processed on the same day itself and it should be packed on the same day. It is transported to different place. So you do not go for stacking the raw material. Then I think the slides will just share it after this. We can skip all this, continuous here, advantage, disadvantage, anyway. So that is the basic of continuous manufacturing. Batch manufacturing, look, it treats product as a group. An industrial production system in which mass produced items are built in batches with fixed changes to each batch. You can see in any medicine a batch number is given. Okay. Or suppose you can take our water bottling plant. Okay. They at a time they cannot produce for 500 liter, 200 milliliter bottle, 1 liter bottle here. So maybe this time they go for a batch of 500 ml bottle. Next they will put 1 liter bottle, then 2 liter bottle. Like this, they go for batches. Every finished product from one batch should be identical. Obviously, in one batch it should be identical. After one batch production, manufacturing equipment and tools are then cleaned and prepared for the next batch. Each product group undergoes a series of steps to result in the end product. It occurs within a certain time frame and guarantees specified quality changes. Then it allows for various product changes such as style, color, size, ensure that each batch like your t-shirt manufacturing company. First, they'll stitch all XL size, then L size, then M size, then S size. So it may go for batches and product is similar in nature. This is possible when products are similar in nature. So we can change the batch size and customize a stage to add a design feature. Again, batch size may be different because most of the people they lie in M or L size. So XL or triple XL size or double XL size, these are very few in nature. And S also few in nature. So example, molds, material coating, computer softwares, newspapers. Like computers are produced, then you need to install the software. So one by one, first Adobe for, then Microsoft Word, whatever, Office. So all this you will go in phases. Newspapers, magazines, machines, cosmetics, food production, chemical tools, equipment. So all this they come under this batch production. Advantage: it allows for greater quality control. It increases equipment and machine efficiency, reduces waste by producing the precise number of goods ordered. Then it helps lower cost by running machines only when needed rather than continuously. Jobs of manufacturing, as I explained. So this method of fulfilling custom or specialized order, the production of goods that require unique processing. So they produce mostly customized product. Most common in industries where production require personalization, such as metal fabrication shop, custom furniture, printing. So due to complex production tasks involved, it typically relies more heavily on skilled labor. So obviously one has to be skilled. Okay, he must be expert in preparing table, chair, sofa set, teapot. So I mean, it doesn't apprehend what type of orders will come. Okay, I may go for, okay, I want for my kid, this is the size of the table, this should be length, this should be breadth, this should be the leg space, this should be the drawer height, all this. So it requires very skilled labor. And it has a longer lead time production because there is no such previously existing drawing or design because as it is customized. So careful planning and scheduling are required. On the flip side, the ability to handle diverse and one-off items offer a significant advantage. Instead of working in an assembly line, different workers are assigned to separate workstations, separate workshops, and production areas. The product, before it reaches its completion stage, must go through each of the stations so that each worker can add value to it before going on to the next. Products that are best manufactured using the job shop type often requires unique methods or sequence of stages, making the process ideal for customization or make to order production. Small batches are often produced through job shop manufacturing. Since this type tends to give a strong focus on quality control, it can be slower as it produces low volume yet highly customized products. These products, but are not limited to specialized aviation parts, ship components, and even industrial machinery. Highly trained professionals handle job shop manufacturing processes to take charge of advanced techniques which are being utilized to achieve quality standards. Now, discrete manufacturing. It uses an assembly or production line So it uses an assembly or production line though it is much more diverse than repetitive manufacturing and allows for more frequent changeover and variations. So you produce it in discrete manner. I mean, it is similar to your batch production, but here the frequency of changing is more. Okay, and it is diverse in nature. I mean, may not be similar type of product may not be manufactured. Like manufacture of clothing, toys. Okay, toy manufacturing, they may not produce similar type of toys, or medical devices are some examples that require this type, as they need to add or eliminate certain components or methods being applied to their current products to account for necessary innovations brought on by trend or demands. So now you are producing a particular type of toys. Maybe you need to change it the design little bit so that some new processes may be added, some new processes may be deleted from that. Similarly, clothing design also. So there you should be ready for any innovations. It is also closely tied to the concept of one piece flow, which is used in lean manufacturing process. It can be used to create various products. Automobiles and aircraft makers use discrete manufacturing process along with many companies who produce clothing, medical devices, toys, and smartphones. Again, smartphones for different models also there may exist different models also. Then repetitive manufacturing. So it's use of assembly and production lines to create identical or very similar products. This feature makes repetitive manufacturing ideal for producers committed to a set production rate. It is an industrial production system that mass produces goods similar in function and layout. Any differences in product design are minimal and do not require major changes in the manufacturing processes. It adheres to a strict master production schedule (MPS) to operate efficiently and meet a specific production rate while maintaining quality. Following a master schedule allows repetitive manufacturers to stay ahead of product demand as production occurs before customers submit orders. Types of production processes that results in standardized output of goods. Identical or highly similar products are manufactured in large quantities using an automatic chain of actions. Then repetitive manufacturing. A kitting process is often implemented to streamline these repeat productions. It aims to achieve high levels of efficiency while producing a large volume of consistently identical items. It is ideal if you have products with stable and predictive demand, and the cycle time from start to finish is typically short. This makes repetitive manufacturing a preferred method for mass production of goods. Electronics, automobiles, durable goods like large household appliances are three common types of products created via repetitive manufacturing, like your TV, fridge, refrigerators, all these. So benefits, then 3D printing, additive manufacturing, you know. So it is construction of three-dimensional object from a CAD model by using 3D model. So it can be done in a variety of processes in which material is deposited, joined, or solidified under computer control, with the material being added together, typically layer by layer. So both X, Y, and Z component are there, so that you can produce 3D. And if you say using two-dimensional thing, you can go for laser etching or laser engraving processes also. Unlike subtractive manufacturing, so this is additive manufacturing. There can be subtractive manufacturing. Additive manufacturing builds up the product from scratch, presenting unique and highly complex design. But in subtracting manufacturing, you have to distract material, take over material. It is also ideal for customization and small scale production. It is often used for prototyping and iteration of products. The additive manufacturing process occurs in three general steps. System is the oldest and most popular approach. Skilled craftspeople produces very item by hand, typically with the help of equipment. Machines used are generally built for a specific purpose and can only help a worker create a single product at a time. It is designed to produce a specific product or a set of products. Like look, earlier days, there was no such design or drawing available. Like plow or bullock cart, there's no such design. Okay, or you can say what you call That's Devi Saraswati holds Bina, any musical instrument. Okay. So for this, because from earlier times, there is no such design, drawing, or you will keep the design in pen drive, material specification, all this. Okay. They go, I mean, from year to year, they go on producing the same thing. So this comes under your custom manufacturing. Each product can be customized to a client specific need and desire. This applies to items produced on an on-demand basis or one at a time. The approach is not practical for products that need to be mass produced. Batches of large enough size may also not work with a custom manufacturing system. This may be a costly and time consuming venture at first, but it also may pay big dividends in the long run. Tailored suits, handmade furniture, wedding cakes are all good examples. Okay. Now, examples of custom manufacturing include certain medical devices, architectural element, or military weapons. So they are customized. Flexible manufacturing, FMS, flexible manufacturing system. It fulfills the same batch quantities as intermittent manufacturing, but with less reliance on skilled labors. Instead, high level of robotics and automation enable machines to rapid recalibrate between different products and lines. Due to speed of changeover, it is sometimes referred to as agile manufacturing. The system requires high level of initial capital investment and expensive pre-planning, but can offer a more favorable cost per unit with even greater flexibility than intermittent manufacturing once the plant is running. A flexible manufacturing system, FMS, is a type of manufacturing system that is able to quickly change between different product types and sizes. So here what happens, you can easily change the design, you can easily change the product, so that in within same workstation, you are flexible to design, to change the design and adapt it. This type of system is characterized by its use of automated equipment and computer controlled robots. Like continuous manufacturing system, the initial cost of machines can be quite high, but these systems allow you to produce more goods with fewer labor requirements. They are also more adaptable to changing marketplace conditions. Process manufacturing. So in this method, goods are produced through a series of continuous or sequential process. Unlike discrete manufacturing where individual units are produced separately, process manufacturing creates products through chemical reactions, mixing, blending, and other transformational processes. Intermittent manufacturing. The company produces multiple identical items at the same time. The nature of the system means the products must be standardized and there is little or no allowance for customization. There is an effective alternative to continuous manufacturing for companies that are not willing to able to make as large a capital investment, but are usually most effective for low volume or limited production runs. It can also be thought of as a batch production, limited runs of similar products, usually fulfilling specific orders. So, although machinery is often utilized, intermittent manufacturers commonly rely on skilled workers able to switch between different products. Products are manufactured in batches based on customer orders, with the production line reconfigured after each batch to make the next set of products. It generally handles small volume of each product. So the best example is your clothing. It's a large scale example which often produces intermittently responding to demand of particular designs. Then mass customization. This is the most efficient type of manufacturing system as it uses assembly line to produce large quantities of products quickly and cheaply. However, mass production is not well suited for products that require customization or have a lot of variation. The convergence of digital decisions or manufacturing may allow customers to design highly complex customizations themselves that are automatically relayed to automated production lines capable of adapting with no change over time. So as customers increasingly expect personalization and the technology becomes more capable, mass customization is rapidly becoming the preferred method of production in many sectors. It allows companies to offer a wide range of product variation without sacrificing the efficiency and economies of scale associated with traditional mass production methods. It represents a shift towards more customer-centric manufacturing, where business aims to strike a balance between offering tailored products and preserving operational efficiency. By empowering customers with choices while maintaining economies of scale, mass customization enables business to meet diverse market demand and foster change customer loyalty. Lean manufacturing. So it's a long list. It is a manufacturing process that optimizes the production to minimize waste in terms of resources, time, and effort, and costs, improve lead times, and increase customer satisfaction. The concept originated from Japan in 1940s at Toyota car manufacturing facility. So it maximizes efficiency and increases overall quality. The use of pull system, there are two systems, pull system and push system. So it follows pull system, continuous improvement, and waste elimination in the production process production processes that characterizes it. It often involves JIT inventory concept, that is just in time inventory concept, and continuously improve principles. Then make to assemble manufacturing. So this strategy, hybrid of MTS and MTO, make to order, in that companies stock basic parts based on demand predictions but do not assemble them until customer place their order. The advantage of such strategy is that it allows fast customization of product based on customer demand. The factory will produce component parts in anticipation of order for assembly. This means that the manufacturer is ready to fulfill customer order as they arrive, but can leave the manufacturer with a stock of unwanted parts if there is no demand. One downside of make to assemble, MTA, make to assemble, is a company may receive too many orders to handle given the labor and components it has on hand. Example is found in the restaurant industry, which prepares a number of raw materials like gravies, different types of gravies, and some raw material half cooked they may keep, and whenever an order comes, they prepare it quickly and give. So example is found in the restaurant industry, which prepares a number of raw materials in advance and then awaits a customer order to start assembly. Then make to order manufacturing allows the manufacturer to wait until orders are received before production begins. This makes it much easier. By, like in other case, they start beginning preparation before the order comes. But here, unless until order comes, they do not start preparation. This makes it much easier to manage inventories and react to market demand. Customers will need to wait for their products to be produced, and the manufacturer will need a steady stream of orders to keep the factory in production and profitable. It entails working directly with the customer to understand their need and desired product specifications. Manufacturing typically only starts after a signed contract or letter of intent, LOI. Manufacturers may generate light prototype but will often hold off on starting manufacturing until further product specifications have been delivered. MTO is the most common in industry where specialized products are being made for a very specific purpose. Aerospace, construction, or technology to a lesser degree are examples of industries where manufacturers will often not manufacture a good until a government entity has agreed to purchase the aircraft or a tenant has signed a long-term lease agreement. So aircraft, Boeing, they do not keep it in stock. unless until they get order. So after they get order, they start producing. MTO manufacturer can often charge a minimum premium for their products as the goods may not be easily acquired in a marketplace. That is especially true, that is, this is especially true for highly specialized goods. In addition, MTO manufacturers often only make a good if the sale is lined up. Therefore, they often never carry inventory. As a downside, MTO manufacturing often comes with uneven product demand that may result in slower periods or business. Mass production. So, manufacture of discrete parts or assemblies using a continuous process are called mass production. Mass production is where a large quantities of standardized products are produced at a high rate using assembly line and specialized machinery. So, the approach aims to achieve economies of scale and efficiency by streamlining production processes, reducing costs and meeting widespread consumer demands. The production system is justified by very large volume of production. The machines are arranged in a line of product layout. Product and process standardization exists, and all outputs follow the same path. Then anyway, characteristics we may skip, advantages, limitations. Now, this is very important concept, try to understand. Theory of constraints, this is otherwise known as TOC. So this is proposed by the Eliyahu Moshe Goldratt. So even I have seen him when he visited New Delhi, I was there. So around maybe in 2007 or 8. So he passed away in 2011. So mostly he is an Israeli. So basically he works in a company, manufacturing industry. So there he observed very minutely. He was there for a long time. He observed minutely, and after that he suggested some improvement, but there he was not able to succeed because nobody listened to him. Then he came out, joined another year. Anyway, all his basically he proposed this theory of constraint, okay, by a novel which is known as The Goal. Okay, its publisher is North River Press. So basically, it's a novel. You can also read that. So it's story sort of thing based on his experience. Then after he proposes, after he learns himself, then he applies it to another company and got success. What is this? So basically, this is a management philosophy or paradigm based on the application of scientific principles, logical reasoning to guide human-based organizations in maximizing their throughput. Throughput, he distinguished between throughput and profit. They are not same. Throughput is the rate at which you generate money in an organization through sales. Okay. Profit means, I mean, throughput. Suppose same thing, he suppose a pen. A pen I am selling at 10 rupees, he is selling at 10 rupees. Okay. I am having same setup of production. He is also having same setup of production. But I can make a throughput of say 4 rupees, whereas he can make a throughput of 3 rupees. Why my throughput is more? Having same year, because I can manage my resources more efficiently. That means I can make money by utilizing my resources. Okay, with same setup. So it's not that he wants to make same profit. Then if his production cost is 7 rupees, he wants to make 4 rupee profit, he will sell it at 11 rupees. But in my case, it is 6 rupees production cost. With 4 rupee profit, I can sell it at 10 rupees. So obviously, I'll attract more customers and he cannot sustain in the market. So he introduced in case of profit, throughput means we have utilizing our resources and with more rate, we generate money through sales. Okay, we'll be coming detail to its mathematical part. Now, what he says, his philosophy is there is no limit to attain the top. Always there is a chance to grow. You cannot say, okay, I have attained the maximum or I have already reached at the top. So always there is a chance for improvement. And to fulfill this, he introduced a term known as constraint. What is constraint? Constraint means, okay, you can understand bottlenecks. Bottleneck means this is a bottle, you are keeping water here, now the neck is constricted. Okay, that means where it cannot come out with the same flow if the neck would have been here. Okay, when demand is more than supply, there bottleneck occurs, constriction occurs. Okay, that means demand is more than supply. Now, in an organization, there may be several bottlenecks. Bottlenecks means any problem. But the one bottleneck which innovates the output the most is known as constraints. We may have 5 bottlenecks. Out of this, the important bottleneck which affects the output the most, that is known as constraint. Okay, that means students can have a lot of complaints. Sir, we do not have good teachers, we do not have good library, we do not have good laboratory, we do not have good food facility, we do not have good accommodation in the hostel. So all these are bottlenecks. But out of this, which affects their career to meet their objective the most? Okay, maybe it is good faculty members. So that will be the constraint. All are bottlenecks. So always, so what is his philosophy? No organization exists without at least one constraint. Okay, so a constraint is a must in each and every organization. Why he proposed this? Because unless until constraint is not there, you cannot improve. Always your aim is to break the constraint. Okay, so now this time let us say we can have very good or excellent professors recruited. So that part is over. Then again I'll analyze my organization. I'll take feedback from the students. Now again there will be 8 to 10 bottlenecks. So out of this, which one is the most affecting the output or the career of the students? That will identify. Okay, libraries, good books are not there. Now we'll try to break that. After that again we'll analyze. So it's a continuous improvement process. So why it is management philosophy? Because unless until you take this presumption that no organization exists without a constraint, you cannot improve it. Because always your aim should be to break the constraint and again analyze. So every organization must be having at least one constraint, and its aim is to break the constraint so that it's a path for continuous improvement of the organization. Now, so everyone strives hard to achieve their goal. Now, mostly in human-based organization, TOC, a manufacturing philosophy or paradigm. So with some scientific principles and logical reasoning, they want to achieve, but it is limited by constraints of the system. Okay. Now, yes, as I told you, so all constraints are bottlenecks, but all bottlenecks are not constraints. Out of all bottlenecks, the bottleneck which affects the most, that will be the constraint. Now, it is developed by Eliyahu M. Goldratt. It's a systems management philosophy developed in 1980s. Boost process performance by looking at the entire process, identifying and reducing bottlenecks, often applied in conjunction with total quality management, TQM, just in time, then account based marketing, ABM. Now, Project managers have always analyzed individual components of a process. Maximizing components may not improve the process. In view of entire process and find the weakest link, capacity constraint resource. That means the constraint which occurs at which resources, that is machines, that is known as your capacity constraint resource. That means I have got 6 machines. For my product, all the 6 machines are required. But the load on which machine is the most, that is the constraint, because it is getting most load. Suppose I have got 5 machines. In a single 8-hour shift, one machine runs for 6 hours, another machine for 5 hours, another machine for 3 hours, another machine is 2 hours. So the one which is running for 6 hours, it is a very stressful condition. But we are not able to utilize the one which we are using for only 2 hours, because rest 6 hours it is becoming idle. So that is not the way we will optimize our resources. So capacity constraint means on which more load will be there, that is your capacity constraint. All projects contains one but not many capacity constraints. So each organization must be having at least one constraint. Then TOC thinking process. It's a philosophy thinking process. What you will change and how to cause the change, how to and what to change to. Okay. Now, what I need to change, what I need to rectify, then how should how to rectify that. Then, if I want to rectify, by what thing I will replace it to. Okay. Now, these are, I think, okay, these things we may skip. Now, look, what he proposes, every real system must possess a constraint, as I explained. It is a factor that limits the system's performance relative to its goal. Now, what Goldratt says, its philosophy, every organization's goal is to make money now and then. Okay, every organization wants that to make money, it is their goal. So the factor that limits the system performance relative to its goal is known as your constraint. Now, bottleneck resource available capacity is less than or equal to the capacity required to satisfy the demand. That means capacity is less than the demand. Constraint, the bottleneck whose performance is directly related to the system performance. Now, anything that prevents the system from achieving more of its goal is known as constraint. There may be internal constraint, there may be external constraint. What are the internal constraint? When market demands more from the system that it can deliver. Suppose I have a producing capacity of 800 unit of some product. Now I get an order of say 1500 capacity. I cannot deny that I cannot take the order to sustain in the market, otherwise I will lose good name in the market. So I have to take the order. So it may be due to equipment. Currently used equipments limit the ability of the system to produce more sellable goods and services. It may be people. You may be having lacking of skilled people. Lack of skilled people limits the system. Mental models held by people can cause behavior that becomes constraint. Policy, a written or unwritten policy prevents the system from making more. Or there can be external constraint when the system can produce more than market will bear. Organization should focus on mechanism to create more demand for its products or services. Now, based on this, now look, there's an interesting one. Based on this, the whole manufacturing plant, we can divide it into 4 types. Vati, V-A-T-I. V-type plant, A-type plant, T-type plant, I-type plant. Now let me come from that side. I-type plant means, I-type plant, look, these are named how a product is produced. From raw material, it has to pass through different resources to become a finished product. Okay. Now, the practice is will start from the bottom to top. Okay. Bottom one is raw material, top one is finished product. Now, here I type means the raw material enters here, then some process, then some process, then finished product. Okay. So, it's a continuous process. Now, in I-type plant, look here, try to understand. In I-type plant, which one is the system's performance rate? Suppose, look, we are riding a mountain. We are 4 people and we have hold our hands like this. Okay. Now, reaching at the top will depend on which one among the 4. The one who goes in not at the end, who goes at the slowest pace. The one who moves at the slowest pace, unless until he or she is able to ride off, we cannot go, isn't it? So, here the weakest link is the slowest link, and this affects the whole output, isn't it? Unless and similarly, there are so many machines. Input goes from one end, comes out at the other end. There are different machines. So, the output will depend upon the rate of the slowest machine, because unless until the slowest machine clears the product, it cannot go ahead. So, the overall output depends on the slowest link. Okay. And another disadvantage in this is, if the chain breaks, the whole system collapses unless until it is repaired or replaced. Okay. Now, this type of thing, I-type plant means 1 to 1. That means one type of raw material, one type of product. Then let us say V-type. I mean, from one product, one type of raw material, you are getting different products. Like say, you are going for taking mutton, say. Okay. The person is say hanging one goat. Okay. So, from that goat, it gives different vendors. Okay. He wants one leg piece. Okay, take leg piece. He wants another leg piece. But I cannot get 5 leg piece from a goat. Understood my point? So, the same way, I am giving it to different meat rendering shop, different persons. Or you can think of, say, blast furnace, same raw material, iron in liquid form, but in the output, you will get ingots, rods, you will get billets. Okay. So, this raw material is meant for all these products. So, here what happens? The raw material meant for others is stolen or robbed by the other one, because I want leg piece, he also wants leg piece. If another fellow wants leg piece of a chicken, it has got 2 legs only. So, that means the thing that I want, it is being robbed by him. Okay. So, this is the robbery or stealing occurs. A-type plant, different types of raw materials, they give one type of product. Okay. This one type of raw material or many to many types raw material gives many products. So, this is known as one to many, this is many to one, this is many to many, this is one to one. Now, look, I-type of plant. Material flows in a straight sequence 1 to 1. Constant is the slowest operation. Brick manufacturing, bottling plant, bakery products. Okay, starting from flour to raw material to baked cake. So, it goes continuously one after another. A-type plant. A-type means A. I mean, many to one. Flow of material is many to one in a plant where many sub-assemblies converge for a final assembly. Problem here in synchronizing the converging line so that each supplier the final assembly points at the time. Example, automobiles, like look here. Look, in automobile sector, what happens? The main chassis comes in the main stem. Maybe this end, the left side door, front door, and left side back door, they comes in a different assembly line. From this side, right side also, they come in different assembly line. This moves in the main channel. So when the chassis is here, at that time, from this end, the door comes and it gets fitted. This back side, left back side, it gets fitted. Similarly, this also fitted. Then it moves a little. Then left wheel, right wheel, they get fitted. Now, synchronization or balancing is important. When it moves, if I reach here, at that time, this line is not coming. I cannot wait. I have to go ahead because that has already reached. Understood my point? So here, main problem becomes synchronization. That is in synchronizing the converging lines so that each supplies the final assembly point at the right time. So that one after other, because all are robots are used. You might have seen so many videos, or if you have really seen any Maruti Udyog you go or Mahindra plant, okay, it comes out regularly in a main assembly line. It moves, the chassis moves, and from the side assembly line balance, it is known as your assembly line balancing, and with synchronization they reach. Then V-type plant, flow of material is one to many, such as a plant that takes one raw material and can make many final products. Rubbing, as I was telling, rubbing where one operation A immediately after a diverging point steals material meant for the other operation. Okay, same water, I am bottling it, say 500 ml, 1 liter, 200 ml, 20 liter, 2 liter, whatever. So the material meant for one is being stolen or robbed by other. Okay, once the material is processed by A, it cannot come back and be run through B without significant rework, like meat rendering plant, steel manufacturer, milk product, same milk. We are going for cheese, we are going for curd, we are going for ice cream, same milk. Okay, so different products. Tea plant, general flow of an eye plant. It is almost general to our eye plant, but here it is many to many or has multiple lines, when which then splits into many assemblies, many to many. Problem is both synchronization problem of a plant. Okay, so it faces the synchronization of a plant and parts are not available for an assembly, and the rubbing problem of B plant also. One assembly steals part that could have been used in another. Okay, because same material, different products. So rubbing will occur. And synchronization also occurs like A plant. So it's a combination of both A and B, so that many to many will be there. Customized devices such as computers, furniture manufacturers, sourcing wood, metal, fabric. So we keep wood, metal, fabric, everything. Then you require this type of sofa, he requires that type of sofa, he requires another type of table. So from same raw material, I'll go for different things. Okay, assembly is in various chairs, tables, and cabinet design for distribution. Now look here. WIP means work in process inventory. Now this one produces say 20 pieces in a minute. This one produces 16 pieces. This one 10, 14, 18. Now look, after he produces, he pass on to the next. Okay, he can produce 20. Now he is sitting idle. He passed on 20 pieces to him, but he can process only 16. So remaining 4 pieces are in each minute. remaining 4 pieces are lying. He passes on 10. He passes on 16 per minute, but he can produce only 10. Now, all resources down the line, even if they are having more capacity, but their supply is less, because this gives only 10 pieces per minute. Even if he can go for 14, rest time he will be idle. So who is overloaded? This fellow. Continuously he is working overloaded, because he is the slowest pacer. Okay. So the whole output depends on this fellow. The output will be 10 pieces per minute. Okay. Now, it proposes 5 basic steps: identify, exploit, subordinate, elevate, and repeat. What identify? First, you identify which one is the constraint, things that prevent the organization from obtaining more of its goal. Then exploit it. Make sure that constraint is doing things that the constraint uniquely does, and not doing things that it should not do. Then subordinate all other processes to above decision. Align all other processes to the decision made above. Then elevate the constraint. I mean, break it. Break the constraint. If required, permanently increase capacity of the constraint or buy more. And next is repeat. Okay. Then after the constraint is broken, elevated, or broken, or removed, then again you reanalyze and go to step 1. That means, as the assumption is, no organization exists without one constraint. So after the constraint is broken, again you analyze and try to identify the constraint. So the process repeats itself. So it is a continuous or ongoing improvement process. Look here, they are all going. The slowest one or heavily loaded, so he is the constant. Okay, so all of you are going together. You cannot leave him behind. So your final destination will depend on him. So you have identified the constant. Decide how to exploit the constant. Then you have decided, okay, he is not able to run or walk. So let us just catch hold of him, just will pull him or push him. Even if this is not feasible, okay, let us put his luggage and put him on our shoulder. Okay, go. Okay, so decide how to exploit the constraint. Then what they did? They pull him at the front, subordinate everything else to the decision of step 2. That means, while you will try to break it or subordinate it, you neglect all other things. Give him the priority. Now, elevate the system's constant. I mean, the constant is broken. Now, again, after this 4, there are 5 now initially. So, after say this is broken, we have removed or whatever. So, now out of this, again you decide who is the slowest one. So, maybe this fellow. Then you repeat the process. If constant is broken in step 4, go back to step 1. Okay. Anyway, so this is the analysis. Exploit here. Identify the constant. Step 1. Step 2, exploit it. Is the constant physical? If no, then you go again. All this same thing. It's given in a logical sequence flow. That POC operational parameters that define constant, anything that limits the system's performance relative to its goal. Inventory, all the money used to purchase things that the system intends to sell, it is known as inventory. Then operating expenses, the money a system spent to turn inventory into throughput, that is heat, light, direct labor, your rent, whatever, these are all operating expenses. Throughput accounting, an accounting system used to measure TOC operations. Now, throughput is the rate at which a system generates money or achieves its goal through sales. Throughput is the rate at which an organization generates money by selling its product. And they are limited by either the plant capacity constant, this is internal constant, or market demand, external constant. Now, these are all operational parameters, operational definitions. You can define throughput, that is sale, okay, sale minus total variable cost by time, that is your throughput. Inventory is money invested by the system to purchase things it intended to sell. Operating expenses, money spent on the system in turning inventory to throughput. Throughput minus operating expenses is net profit. ROI, return on investment, net profit by average operating assets. Cash flow, it reflects all the sources and uses of cash in the company for a financial period. Now look how beautifully it is arranged, all the terms. Cost of goods sold, selling price, administrative expenses, all these are operating expenses. If you subtract sale, this is non-operating income. If you divide non-operating income divided sale, it gives margin. You multiply margin with turnover, you get return on investment. Then cash, accounts recoverable, inventories, their current assets. Plant equipment and other assets, non-current assets. Both sum of these two, current and non-current, operating assets. So sale divided by operating asset, turnover. So this is your ROI, return on investment. Okay. Now, we'll take a break of 2 minutes, then we'll go to other area. Hello. Hello. Is it working? Working. Okay. So let's start then. Now, next we'll have a case study, not case study. Here directly we'll be applying operation research to a real life problem. So a modeling is done, which is outsourcing model. Now, under what circumstances we'll go for outsourcing? When demand exceeds more than the capacity of a manufacturing plant, then generally we go for outsourcing this. Outsourcing means getting things from an outside contractor or a vendor is known as outsourcing. Now, what can be outsourced? Suppose I am producing some goods, my capacity is say 1000 unit in a month, and in a particular month it exceeds more than expected, say 1500 pieces I got an order. So I cannot deny accepting the order. Then I'll lose in the market. I'll earn bad name in the market. So what I can do, I'll try to optimize my existing resources. Whatever the best I can get out of this. For rest, either I may outsource some operations. Let us say one operation is welding. Suppose I have got constraint out there, my welding machine capacity is not able to produce 1500 things. So in that case, some of the welding operations I get from outside contractor, it may happen. Or I am producing say 4 types of products. Let us say this is 500 ml bottle, and I am producing 1 liter bottle. I am producing 200 ml bottle. I am producing 2 liter bottle. Okay, and each one is having same type of manufacturing processes, because the processes are similar in nature. Okay, and the raw materials are not same. For 200 bottle, the raw material will be less. For 2 liter, the raw material will be obviously comparatively more, and the raw material price is different. Now, the selling price of everything is different. Now, the profit margin of everything is different, all the products, and I have a combination of, depending on my resources. Suppose I want to go for manufacturing only this type of bottle for the whole month, then this may be 1000 pieces. But if I go for producing 200 ml bottle, maybe I may produce 1200. If I go for producing 2 liter bottle, I may produce say 100 pieces. So produce, and if I go for combination also, it may be different. So companies, they come in a difficult situation, how much quantity they will produce in-house by optimizing their existing resources, and how much rest quantity they will go for outsourcing. Okay, so for that we'll be discussing this model. Now let us consider a production facility consisting of n resources. Resources means you can say operations or machines. Okay, machines means first from pre-form, these bottles are to be formed, the bottle has to be made, then the cap, then this pasting, then filling it up, then this printing label by expiry date, price and everything, then packaging, then so all these are operations. Now n resources means 1, 2 in total, capital N is the number of resources, and all these products are to pass through this number of resources. Manufacturing m different products, like I told, the product means 200 ml bottle, 500 ml bottle, 1 liter bottle, 2 liter bottle, like this. So they are having in total m different types of products. Denotes J's capacity in working seconds in a shift. That means what is this? N is the number of resources, M is the number of products. Okay, it denotes J's capacity in working second in a shift. That means for producing a particular type of product in particular machine. What I can say? Suppose this is a machine. If I go for producing one piece of this through this machine, it takes a 10 minutes. Maybe for producing 200 bottle, it may take 5 minutes. For producing 2-liter bottle, it may take 20 minutes. So that means for a particular product, for a particular resource, the time working second is different. Now Aij, it is the number of seconds required by resource J to process product I. Okay, out of capital, out of all these resources, Aij means that is how much time or how much second required by J resource to process one piece of I product. Okay. Now, RM is the raw material price for I product. MP is the market price, that is your selling price, you can say, producer's price. DQ is the demand quantity for I product. So in total, I am having how many products? Total M type of products. So I varies from 1 to M. So DQI, the market demand quantity for product I, due to its capacity constraint, the company can only manufacture XI unit of product I. That means XI is less than DQI. That means company can produce 100 unit of 200 ml bottle. Okay, 100 unit of 200 unit bottle. So 200 unit is that bottle, 200 ml bottle is characterized by X1 or X2 or X3, whatever, and the demand quantity is 200. So this is the variable, Xi is the variable which must be less than DQI, because you cannot produce more extra, what you will do? So this is a capacity constraint, I mean demand constraint. Okay, you have to produce something less than or equal to this quantity. Now, it is a company policy to supply all the market demand in order to prevent other major competitors from penetrating into the market. So, company's policy is you always accept the order. You cannot deny, otherwise others will penetrate into the market. And at the same time maintains the company's reputation for due date performance. You must meet the deadline of the supply date to earn good name. Otherwise, you will be out of the market. The company therefore commissions outside contractors to fill the gap between, so it bridges the gap between the quantities that it produces and the market demand. So if any extra quantity you got, so there are outside contractors to bridge the gap between the two. Now contractors purchase their own raw material and delivers product I at price CPI. So what is CPI? That is contractor's price for product I. That means maybe if I produce this, for me it is 7 rupees. I can sell it at 10 rupees. But if I get it from outside contractor, for me the contractor price for this will be 8 rupees. Okay, if I produce, I do not have that capacity, but if I would have produced this in my factory, it costs me 7 rupees. But contractor price for this is say 8 rupees. So it is better if I would have produced it at 7 rupees and sold at 10 rupees. Okay, I do not have capacity. I may get it at 8 rupees, sell it at 10 rupees. So this is CPI is the contractor price for product I. The company's additional expenses such as labor, energy, financing are treated as operating expenses. So operating expenses is fixed. It does not depend on quantity, like electricity bill, house rent, whatever, all these are operating expenses. So this is a lump sum amount, fixed. Management aims to maximize its throughput from manufacturing and from outsourcing product. So by this model, we will be able to decide how much quantity we will make in-house, how much quantity of what product will get from outside contractor. Now, the throughput from manufacturing, if I produce 1 unit of product type I, what is my throughput? It is selling price minus raw material price is throughput. How we define throughput? Throughput is selling price minus raw material price, because raw material price is same for me, same for contractor, same for anybody else, unless until he does something unusual. Suppose he has stolen some raw material here, or that not the ethical policy. So raw material price is same for everyone. Now the difference between selling price and raw material, there lies the game. Whatever remains, how you utilize that, that is the throughput. Okay. So if I can effectively manage that, I can make more profit. So the throughput, if I go for producing 1 unit, for 1 unit the throughput is selling price, market price minus raw material price. How much quantity of I am producing? Xi. Okay. Xi is the quantity of I that I am producing. That means from this I am producing X1, from, can you give that one? From this type I am producing X2. Similarly, from another type I am producing X3. So these are the things. So for this, MPI minus RMI, maybe MP1 minus RM1 into X1 is the quantity I will be producing. So total throughput of for this product is Xi into MPI RMI. Similarly, say this is product 2. So what is the throughput for this product? That is MP2 minus RM2. What is the quantity of this product? X2. So what is the throughput by manufacturing this in-house? That is X2 into RM2 minus X2 into MP2 minus RM2. Understood? Now, to satisfy market demand, the company orders a quantity of DQI. Now, how much order I got as tender process? DQI. But DQI I cannot produce. I can produce only XI. So this rest amount I have to outsource, DQI minus XI, from outside contractor, generating a throughput of, now what will be the throughput then? Selling price is this, then contractor price, because for me there is no raw material, because this quantity I am getting from outside contractor. So for one piece of contracted item of product I, what is the throughput? Market price minus contractor price. That is the difference in my selling price and the contractor price that I am buying from contractor for contracted unit. Accounting for, so for the total quantity of outsourced, how much you are outsourcing? DQI minus XI into this one, MPI minus CPI, product I unit. So if I consider a particular product, how much I am producing in-house? XI. How much I am getting outside? DQI minus XI. What is the throughput of this product that I am manufacturing inside? This one. What is the throughput of outsourced of this item? This one. So what is the total throughput of this product? This plus this. Okay. Look, XI into MPI minus RMI, DQI into XI minus this. This is for one product. I have got how many products? M type of products. So it will be summation I is equal to 1 to n. This is the total throughput. Now from total throughput, what is throughput? Selling price minus raw material price. Now I have spent operational expenses as a whole. If I make it minus, the rest of the thing I will optimize. Okay, whatever remains, what is that? That is how I can utilize my resources to get the optimum value, because all fixed things gone. Selling price fixed, raw material price fixed, operating expenses fixed. So only the variables are this. Okay. So the product mix problem can now be expressed in standard linear programming format as this thing minus operating expenses. I is from 1 to m, and you have to maximize this. Now, look at this beautiful relation. Now, if you just multiply this into this term, it will give rise to 4 terms, and you simplify this. So, plus minus cancel. Now, look here, xi into mpi. What is the symbol? Plus na, xi into mpi. Here you will get xi into mpi minus. So, they will cancel. Okay. So, what remains? Okay. Now, linear programming problem means this is my objective function now. I have to maximize this. Okay. Then what is the constant? One is demand, because xi cannot be more than dqi. More than the demand I will not produce. So this is demand constant where I m types. Then one important thing here, observe. But as I told, this is one machine. Let us say this is my grinding or welding, whatever machine. Now all the products have to pass through this, but it cannot take all the products at a time, this machine. After it finished one product, then it will take another product. Okay. So suppose for producing this, it takes 10 minutes. For producing this, it takes 8 minutes. Oh, sorry, 12 minutes. Say. Okay. So after producing this 10 minutes, if I put this, it will take 12 minutes. So for all this time, it has got particular, I cannot run it more than the available time. It is available for one shift, say. Understood? What is that? That is my Bj. Bj is the total available time of this machine. Okay. So whatever I may give, what is Aij? What is Aij? Aij is the number of seconds required by resource J. This is the resource. How much time it will require? J is the resource. This is J. For I product to process. Okay. So for processing one unit, it is taking Aij time. What is the quantity you are doing? Xi. Look here. Xi is the total quantity of this. For producing one quantity, it is taking Aij time. Okay. Similarly, for producing this, it is taking Aij time. J is fixed. This will be A2J, and X2 is the quantity. I'll add it up. Suppose there are how many products? M products. I'll add all this time of all machines. This must be total available time of this machine. Suppose a day is 24 hours. I cannot run it more than 24 hours in a day. So that means I have a resource constraint. Okay? Understood? Even if I run 24/7 my machine, there is certain limit. Beyond that I can't go. If the demand is more, where can I get? So this becomes a constant. So this one is known as demand constraint. This one is known as manufacturing resource constraint. Now, as I was telling, look, xi into mpi plus xi into mpi minus xi mpi minus xi mpi plus cancels out. Remains xi rmi dqy mpi dqy cpi xi cpi. Now xi is the variable. You take common this, because this is cancelled now. xi mpi cancel. Now where xi term is there? Here another xi term is there, because xi is the variable. If I take common xi, what remains? Cpi minus rmi. Okay. Then What else remains? If I take dqy common, MPI minus CPI. Now look here. If I take xi common, CPI minus RMI. And this is MPI minus CPI. Now look here. What is MPI? Market price of I, selling price, constant. What is CPI? Contractor price of product I, constant. DQY, demand quantity, constant. Now the whole thing with summation of this is a constant. Operating expense is a constant. Now you separate all these as a constant. Only variable is xi term. This one remains. Okay. Now you solve. Look how the big objective function. The objective function initially was so big. Isn't it? Now how it is simplified now? It is simplified to only this much. So whatever you will solve for x1, x2, x3, that will give the quantity that you will produce of this type, the quantity that you will produce for this type, it will give. Okay. Now, look, what is this one? CPI, contractor price. That means for me, it is my purchasing price from contractor. For contractor, it is contractor selling price. Isn't it? CPI is contractor selling price. RMI, I told, it is same for everyone. So, contractor selling price minus contractor's raw material price. That means what is this? This is contractor's throughput. For me, my throughput is selling price minus raw material price. For contractor, it is contractor selling price minus raw material price. So, that is contractor's markup. Contractor's throughput into what is xi? Xi is the quantity that I am producing in-house. So, you solve this linear equation with these constants, these two constants. Whatever will be the value of different x, x1, x2, x3 like xm, these number of quantities you will produce in-house, rest from dqy, whatever after subtracting minus, that quantity you will get it from outside contractor. Understood my point? Okay. So this model helps any organization to decide under critical conditions where demand is more than their capacity to decide how much quantity of what type of product they should produce in-house and how much they are outsourcing. Now look, you take any car, say Maruti. Maruti is not producing the glass, front glass or window glass. Window glass may be Saint Gobind. Tire, Maruti is not producing. Either they are getting it from Seat or Apollo or Bridgestone or Yokohama, like this. They are not producing. Some of the product they may get it from other subcontractors. They are producing main is the engine one. Okay. Understood my point? Suppose tomorrow Maruti will know we will produce our glass components, or we will produce our bearing guns. Bearing means it may be Tata or NBC producing, or they will say, okay, we have got a lot of varieties here. Now it will be cheaper for us or convenient for us if we will produce our what is that, tires. Okay. So in that case, where it happens, because you cannot manufacture everything in-house. It will not be viable and feasible. So some of the things you need to outsource. So this will help you in that, in analyzing. Now look, this is how beautiful the relation becomes. Contractor's markup, I mean contractor's throughput. You can think throughput as profit into the quantity that I will be producing in-house. This product will give rise to a value which will give rise to the quantity that I will produce in-house. So the new simplified formulation of the linear programming problem ignores the constant expressions in the objective function. So in the objective function, what excess things were there, now it has become simplified to only this, subject to this. Okay. Now, suppose there are more number of varieties and more number of resources machines. It is not difficult. This becomes a simplex problem. Okay, in linear programming, simplex problem in operation research. It will be very big matrices. Okay, there are different methods of solving simplex problem. So you cannot solve it by pen and paper easily. So there are softwares available. Okay, like Lindo Thora optimization software. It's very good for this LPP. Okay, so you take all the data. What are the data you require for each product? If you take the price of raw material, you take the look here. There is no selling price. It is silent about selling price of each product. Okay, this is vanished. Only you require, if you get it from outside party, what is the cost, what is the raw material cost, then you can get it. Then what is the demand quantity? Okay, how much is the time for which the resource is available, and what is the processing time in each machine? Maybe grinding operation, polishing operation, shot blasting operation, welding operation, heat treatment operation, whatever may be the operation, or micro manufacturing, that offering that operation, whatever. You take the operation time of different products, that data is required. Then you can easily decide and solve. So the implication of the last expression are that product price, cost of raw material, total working hours per product on hourly rate are totally irrelevant. Okay. So product price, they are irrelevant to the outsourcing decisions. Only two variables are relevant. One is this, other is this. Okay. So now, anyway, now we can conclude it in this way. Operation research provides a powerful tool for manufacturing optimization. It enhances productivity, quality, profitability as well. And it is essential for modern competitive manufacturing age, for manufacturing industry. So thank you all. So if you have any queries, you may ask.
Thank you for the nice presentation.
Welcome.
Really informative.
Yeah.
I have one doubt.
Yeah.
Can you clarify me what is the difference between profit and throughput? Is it same?
No. Profit, look, I am giving you an example. Profit is the manufacturing. How can I decide the profit? Profit is selling price minus manufacturing cost. This is profit. Okay. Throughput is selling price minus raw material. So where lies the difference? Like if it is profit, for you, the manufacturing cost of this product may be 10 rupees. For me, it is 8 rupees. But the raw material price for this, for you, it will be 2 rupees. For me, it will be 2 rupees. Now, why for me the manufacturing cost is more? I can effectively utilize my human resource. You have 3 managers, I have 2 managers. Okay. You have unnecessarily taken 1 acre land. I have taken 0.75 acre land. Your house rent is more. Your production capacity is more. What production capacity more? Maybe less. Mine is more. I have got sophisticated machines. I have got 10 number of employees. You have 15 employees. But 10 number of employees, I can effectively manage them. You cannot manage. That's why your manufacturing cost increases. Okay. So your profit is selling price minus manufacturing price. And in manufacturing price, raw material price is included. So throughput is what? Selling price minus raw material, which is fixed for both of us. Now, whatever remains, in who utilizes it in the best way, he will be the winner. Can you get this? So that is the difference between throughput and profit.
Thank you.
Okay. Any more question? Okay. So let's wind up this. So thank you for patient listening and very interactive session. Thank you.